Hello everyone, I'm Tobias Hines, and I'm going to be explaining my group's topic, vector space models and how it relates to the real world. So what is VSM, or the vector space model? Well, simply, it is a search engine that utilizes vectors to retrieve information efficiently. It is widely used in online searching, such as Google, Bing, or DuckDuckGo, where words or queries are compared against a database. Everything in this model is a vector in some high-dimensional space, be it words, documents, queries, or etc. There also exist many different versions of this model that excel at different tasks. Before we jump into establishing vector space models, there are three things we must consider first. One, what are the total dimensions of the space? As, say, if you're querying the entire English dictionary, you would have a space that's over 300,000 dimensions. Hard to visualize, but it's possible. Two, how to project words into said space. And three, how do you compare the vectors created inside of the space? So going step by step, we first need to index a document. We do this by extracting the contents of the document and then ignoring high-frequency words that we deem insignificant, such as the, for example. We then weigh the terms inside the document by looking at its term frequency, collection frequency, and length normalization factors. After we've done all this, we then compare the values that we get in our document vector, which we establish through indexing and weighing, and compare it to our query vector. Here's an example query, just to give a better idea of how the vector space model works. So our query is, are cats friendly to play with, which is a fair question. Our first document states that cats do not play with dogs, and our second document states simply, friendly cats. Here we have established a few matrices to play with based off of our example query. Our green query vector here is consistent of all ones, relating to the words within the query question. Our first document, as you can see, consists of 3 ones, and that relate to the words matching with the query question, which would be cats, play, and with. Likewise, our second document only consists of 2 ones, as that's because only 2 words in the document match, cats and friendly. If we were to compare these documents to the query, document 1 would be seen as more relevant to the search, as it has more words matching to the query than document 2. Here's a simple visualization of what the query vector would look like within a 2-dimensional graph. Here's a 3-dimensional graph to show that as you increase your wordage of your vectors, you're going to get more dimensions. And we relate these documents together through their angles with the query vector. We find this angle through the dot product and taking the cosine inverse of it. So as theta is approaching 180 degrees, the document becomes more unrelated. And as theta is approaching 0 degrees, we can see that the document would become a better match, or more relevant to the query. There are weaknesses to the vector space model, however, such as word weighting. If this is not done, the words such as the will have similar precedence as presidential, which can cause issues to relevance. Other issues, such as frequency and synonyms, can also be an issue for the vector space model. For instance, if a word has 2 different meanings, then context within the document must be used to determine which word is being used. And frequency, if that is not taken into account, then the focus of queries and/or documents may be lost. For instance, if someone is repeating the word dog many times, but the document isn't actually about dogs, it could confuse the model entirely. Now, the advantages of the vector space model. When compared to binary and Jacquard, VSM is much more accurate and eliminates many issues plaguing the other two. For instance, binary searching is fast, but succumbs to the issue that a document either matches a query or doesn't, which prevents a lot of documents from being shown. And Jacquard does not take into account the order of words nor the frequency, and has the same issues that binary does. One of the big companies that use vector space model is Google, and they put a spin on it by having robotic crawlers go through different documents to the web to create a search index, making a large vector space possible and easy. Another corporation that does this is Bing, but they do this through comparing queries to other queries and comparing user click patterns. That is it for this presentation on the vector space model. Hopefully it was fine. Oh well.